All right, would someone be willing to read for us the first paragraph here?
I got it.
Other than Isaac, maybe.
I got it.
We hear Isaac a lot. Go ahead, David. Read actually maybe the whole first half of this. Everything on the screen, basically.
What are you doing? You remember it back from last year about the famous race between the tortoise and the deer. The children's story.
The tortoise.
Turtles.
Yeah, they call it turtle.
And the hare mocks the tortoise for being slow. The turtle replies, slow and steady wins the race. The hare says, oh, we'll see about that. And challenges the turtle to a race. In the task, we model the distance from the starting line from the boat the turtle and the hare traveled during the race. During we will consider only the journey of the turtle in the race.
Yeah.
Because the hare is so confident that he can beat the turtle, he gives the turtle a 1 meter head start. The distance from the starting line to the turtle, including the head start, is given by time.
Right, d of t equals 2 to the t. A function that should not be at all unfamiliar to you now. Seems like we've said everything there should be to say about y equals 2 to the x, right? But I think we have more to say. I think we can still suck this more marrow out of it. There's more to say about 2 to the x. And I think you're going to be surprised by some of the things you hear today. You're going to like this. Now, one thing that is interesting is this is the distance time function. So do you understand what it's outputting? You input the time, and it tells you where he is in the race. Or she. She.
Yeah.
Is Shelly a girl turtle? Okay. Shelly, the turtle.
Shelly was the sister.
Well, no, Shelly's the sister, and she's the one racing. They're watching their sister race. Shelly is her, I think. Am I reading that right?
Wait, the tortoise
I thought it was like the sister of the race.
And they can see their darling tortoise sister, Shelly, through the value of persistence. So this is a distance function given a time. Why is it true, by the way, that she gets a 1 meter head start? Why is that obvious from the equation? If you plug in 0, where is she already? 1 meter away, exactly, okay. So go ahead and answer number 1. Don't spend a ton of time on number 2, but you can answer that. And number 3 and 4. And we'll come back together in a minute. Watch your good.
Excuse me, but this is not realistic.
Do you actually remember this problem? I was going to say, I thought it was a little laughable that they said, oh, you'll remember from Algebra 1
I remember.
this problem.
I
And I was like, no,
this.
they won't.
Excuse me, this tortoise is. How fast is the hare?
I know. Yeah, I would say that this tortoise is fast. I would say that.
You know, it might be like that commercial of the Super Bowl where she's driving a car.
Maybe she's driving a car. Maybe she's like Flash. Zootopia.
Flash, flash, over here.
She like rolls down the window.
I love that. Or David.
It's a very interesting question. We just want to know where we should be located, like on the course, right? So I think
1 million.
this could happen. All right, I think everyone has the answers to the first one right here. Okay, so the first one, what is it? 10 seconds. Jessiah, what's that? Jessiah, what's that one? Wait, guys, I want to hear. Say it again. D of 10 is what?
1,024.
Okay, 1,024 meters. And Noah, what'd you get for 20 seconds? Where is she located at what point on the course?
1,048,576.
This is 6 times.
Did I just write that correctly?
Yeah.
Okay. Put some commas in. Meters. All right. So yeah, on a scale from like slow to fast, what would you qualify? This is like a very, very mathematical designation. Would you call her? What would you call her?
Exponentially quick.
She's fairly
Ten
fast, I would
times
say.
faster
Like,
than Usain Bolt.
she's just like a little fast. She just happens to be at 20 meters, at 20 seconds, she's 1,000,000 meters away. That's all. I mean, that's all. I actually did. I ran the numbers for you guys, and
It hits the sun, right?
yeah. And you remember that discussion where we were
Yeah,
talking about
oh, yeah.
how high above the school and like all that kind of stuff. So I ran the numbers, and it turns out at 70 seconds, Shelley leaves the Milky Way galaxy. So like, let's just like have a good laugh at this problem, because I'm not sure like to what extent this is realistic. There is actually one other piece that, even if she was like a super fast particle, that makes me think that, I haven't actually checked the numbers on this, but actually makes me think she might be violating the law of physics too. You know what that? We do have like a bound in nature.
She ran so fast, she's.
Yeah.
She must have got struck by lightning.
We do want to hold to the fact. I mean, I think she might have exceeded the speed of light. That would be a problem.
Then she would turn into
So
energy.
let's just pretend maybe there's a domain of validness for this, but anyway, let's just keep going, recognizing this is a little strange, but let's keep going. Yeah, she like that happened in like 35 seconds.
She's booking it. We need to run our cross country.
Don't labor to answer number 2. We've done this before. I mean, you can describe a couple of the features, but don't, write a couple things down that you remember about 2 to the x. But then move on to the question on number 3 and 4.
64 meters per hour. 1 second.
What's funny?
It only takes her 6 seconds to travel, so I guess it would be. And at 10, she's at 1,024. This is.
Why are you on the back?
Yeah. And did they have
He's beaten me before, but I've been slow. If you only beat me by 4 seconds, he's that.
Oh my god, why can't we beat him as well?
Because we never raced together. They're in different age groups. What? No. Hey, if I go fast enough, I will. If I run faster, I get a faster time. It's scientifically proven that. Hey, what if I run this back? I can just run Shelly's back, and bam, I'm done. Yeah, do the work, Megan. Do it in 20 seconds. By the time the hare finishes his race, Shelly's gonna be out of this known universe.
All right. I think I'm ready to answer these questions here. 3 and 4. Have you done those yet? Don't labor on number 2. I'm sure you said some of the normal things. Talk about its shape, maybe talk about its domain and range. Talk about does it have an asymptote and what is the equation of that asymptote, etc., etc., etc. Okay. So number 3, give me the answer there, Paulina. You haven't done that yet? Okay, go ahead. When you're ready, give me the answer. And David K. on number 4, when you're ready, give me the answer there. When the question is not where will I be at a certain time, but the question is when will I be at a certain place, right? On both 3 and 4. So think about that. They've given you some pretty nice values, haven't they?
Ooh, does that mean after 1 second has passed, she'll be at 0 meters?
That is
After,
at 1.
wait, no,
No,
after
at
0
0
meters.
seconds. She's at 1 meter.
That's a really shady.
No. Yeah. Whenever you have it, Pauline, what do you do? You have this yet? So T is 6 seconds.
Ooh, does that
Okay.
mean they have to wait?
And down here, David, what'd you get there? When is she at 1,024 meters? Figure that out. All right, come back to me. So do you agree that at 6 seconds she'll be at 64 meters? Okay. You see, you're feeling why this question is a little different? I hope you can sense why this is a little bit of an interesting question. I mean, it feels like in some sense solving some of these equations, we're asking like 2 to what power gives 64, right? It's an interesting question. Anyway, so down here, 2 to the what power gives 1024. Did you figure it out?
Okay.
10? Did it work? Yeah. You guys all agree with that? 2 to the 10th apparently is 1024. And again, nice, isn't it? 3 and 4 both have nice answers. So that won't always be, it's certainly you'd have full permission to ask about another number. It's just really nice that the people who are asking here and here happen to be asking about a certain nice number. But certainly you might ask about another value. Before you go too far, I know some of you are already graphing this, and as I look out there, and I've seen some people graphing this already, I see some wrong graphs. Okay, I want to make sure to caution you about what we're trying to show here. Read this sentence above the graph carefully. It says, draw a graph that shows how long the tortoise family will wait to see, that is, will give the time until they see Shelley run by at a given location. So what do you think reading that is the independent variable and the dependent variable?
Location
Time.
is independent.
Which is which?
Which is the no. It's the independent.
Which is the independent variable?
Oh, distance.
Given a location. Yeah, exactly. So the independent variable I want you to think of as, because they said so, I want you to think about as the distance. The dependent variable I'd like you to think about as the time. Keep in mind that's in the spirit of questions 3 and 4. I give you a distance, you give me a time. You understand how this is this will be maybe not the graph you're used to. So what's along the horizontal axis? By convention, yeah, by convention of the human race, we've all decided that we put the independent variable here along the horizontal axis. So if you agree to continue doing that as a human, let's do that. By the way, that is an artificial construction and an agreement by the mathematical community. I'm sure aliens do it differently. I don't know. And then along this axis, I guess we'll put time. Okay? Is that cool? Well, let's see what that looks like. I just want to make sure that's clear before you construct a completely wrong graph. All right, now you can go ahead. We've already computed a couple values on it, right? But pick some strategic x values, right? Or excuse me, d values to think about. Ones that work nicely for you. Compare with what your group members are getting to, of course. Is this like making your brain do new mental gymnastics a little bit to like construct this graph? It's interesting, right? It kind of feels familiar, but kind of. It also kind of feels uncomfortable. Give me 1 point on the graph. Shout one out. Give me a couple different. We'll hear from a couple different people. Did you get a point on the graph? Just one. 0, 1. So 0, 1. That's because Shelly has a distance of 0 away from the starting point at time 1 second. Is that what you meant to say? All right, 1, 0 is definitely a point on the graph. Her position is 1 meter, isn't it? When the clock is at 0. So I like that. Give me another one. And have another good point on the graph. Another convenient point on the graph. Anybody? What else is on there? Give us another one, Daniel. 1, 2, 1. Okay. Ajit, give me another one. You got another one? 2, 8. 3, 8. 1, 2, 3, 4, 6, 7, 8. So again, you're saying that we'll be at a distance of 3 meters at 8 seconds. Is that what you want to say? Where are we going to be at 8 seconds? I think the answer is a lot more than 3 meters. So is that what you meant to say?
No.
What did you mean to say? I know, like I said, this makes your head like, ah. Give me a distance that you know the time for, right? Yeah, well, like, so what are you saying? Tell me what you just said.
Like, for 3 seconds, you get 8.
Right, or say it the other way, like, if you're at 8 meters, then 3 seconds is when Shelly will arrive there, right? So, 1, 2, 3. Okay. Anyone have another one? Wait, 3, 8? I mean 8, 3?
You put 8, 4.
I know, but we don't want either one, do we? 8, 3 is what I want. Oh, we're missing one interesting one in between too. What else? What's another nice point in there? 4:16.
16:4.
Oh, 16:4. Okay. I mean, we're all doing that, right? We're all like kind of getting all mixed up in our head. Also, 4:2, right, is on there. No one said that, but right? Good. I don't think I can put any other points on there that are nice, really. Just by my scale. The next nice one would be what? 32, 5, right? And by the way, is it right to put a curve here? Or does she have a distance? Can you ask the question at other places along here? The answer is absolutely you can, can't you? At other distances, you can ask for the time. It just will be a not nice number. Though, I think you know how to do that now, right? Like if I ask for what about at d equals 10, what would t be? That was the equation you solved yesterday. We spent a little bit of time figuring out what is the x value that makes 2 to the x, 10, right? It's like you could ask for the other values, they'd just be not nice. Great. Isn't it interesting? I mean, I don't think we've ever done this. This felt a little different, a little weird. So keep going. Well, I want to make some more observations about that graph before we're done today, that's for sure. But keep going. Number 6 should be like a review activity.
What is
right?
invertible?
But then on number 7, don't make sure you have a little conversation with your group about this. And if you think you know the answer, if you think you know like the word to describe this, don't say it too loudly. Just share it with your group.
What does invertible mean?
I don't know. I haven't gotten to that question. I only know about questions 6 and 7.
Hey, thank you for that.
Like I said, don't give it away if you figure out what number 7 is. Except you talk to your group about it. one here. What did you get? Guys, by the way, I'm just realizing too that I have a couple calculators, but come Thursday, like today, it's fine if you're, like some of you are using your phone or whatever else to get these, to do some calculations. Thursday's quiz is calculator active, and you will need a calculator for a couple problems. Please make sure you bring your calculator if you have it at home or something like that. I only have a couple of left.
What's the quiz on?
SLT 13 through 19.
Is
Not,
this 19?
no, it's just one.
Oh, so like that.
I mean, I don't know that we'll have too many ones like this. Is technically like prerequisite, but
So what would it be
I
like?
want to focus on stuff that isn't new here.
Like that.
Yeah. Go back and look at your worksheet.
Well, I can do E. I can do E. I don't want to do E.
Well, that's why you do a calculator.
I forgot all about E.
Well, go remember.
I got 8.
Great.
I got 8 1. I got 8 1. I got 8 7.
So Sam, you got the other guy. Like I said, I think most people have an answer to number 6. Please, again, let me invite you to have a discussion with your group about 7. I want you to think about what the relationship is, if you haven't already, and we'll give it away in just about a minute if you haven't heard what it is yet. You guys come up with the answers.
What's the
Do we have homework?
Relationship for number 7. We will. I have a sheet I'll give this. So you guys come up with a relationship for number 7.
Can I have the homework now? I'm done.
What? Oh, yeah.
7.785. All right, hey guys, did you get 7.785 or something?
No. Way too high.
That's too high. 2, 1, 1. Well, 2 is too high, but I think it might be closer than 1.
Because you get 220.
All right, what's the relationship between the graph you just constructed a second ago and, guys, and the graph of just 2 to the x, which you graphed like 1,000 times in the last week? What is the relationship between those two graphs, between those two functions? What's the relationship between the original function 2 to the x and this function that we just graphed? What is it? What's the relationship between this graph and the graph, this one here, and the graph of 2 to the x? We're running a little short on time, so Johnny's just going to have to say it again. They're what? They're inverses. Yes? That gymnastics you're doing with your brain should have felt very familiar. That's the inverse gymnastics, right? Every point is like AB. Oh wait, no, BA, right? Doesn't that sound familiar? This is the inverse function. So I want you to think hard about why. I have some questions about that. Like, why are we guaranteed that the inverse is a function? Is it really a function? Does it obey the definition of a function? And what does this mean for our lives? What are the properties of this new function? Could we even come up with a rule for this function?
No.
I mean, this is a very interesting question. When we're asking, what's the inverse of x squared, you constructed the graph, but you also knew that that was the square root function. What is this, though? I have all sorts of questions. Yeah, I will not check this. I will not check this till Friday.
Okay. But you're hurt, you are.
Because Thursday,
You're hurt. Like you just like got me by car and I'm like, hey, go to the
David.
Yo!
Oh, you got it? Done?
No.
Did everyone get the homework sheet?
No, you get hit by a car. No, it's wasting your time. They're making you lose energy.
You have a calculator? Yeah. Bring your calculator on Thursday, please. See you later.
Start with the start counting a non-zero. If they're in a decimal, start counting with less than 3. That's not right. And then if they're in a decimal, you only count the non-zero.
7. Good job, Danny.
I'm sorry that
Does that look okay?
I was just wondering, like, what exactly was the pattern that caused the time to define positive sign?
I feel like that should be all here. Yeah, look at the second representation they gave you. Think about it. Yeah. I think for each one of these SLTs, have you already looked into Google Classroom as all the Google Drive stuff? I mean, I post all the documents and all the solutions and everything. Have you seen that? Okay.
No, well, I see like the lesson things.